Good morning, everyone. She said, my name is Joel Guth. I'm a longtime MCA member and a longtime masonry contractor since 1983. I'm going to share some of what I've learned about the silica and silica dust issue over the last 15 to 18 years and try to condense it down into as concise a package of information that you can take back with you. I know that your time is valuable. I understand that. So we are going to try to be as productive as possible and focus on four main points. What is silica and why you should care? What is the OSHA silica PEL, this 100 micrograms per meter square? And third is, what is my exposure? You as the contractor, for your company, for you and for your employees, what your exposure is. What you need to know and what OSHA allows. And also the fourth point is, what are my options in dealing with or solving this silica problem? So we'll try to wrap all that up. There's a lot of stuff to cover. I really encourage you to type any questions you have along the way, because if there's a point that I didn't quite get, I don't want to move on and have you miss it, because I know for me, I like to follow along step by step. So please, any questions along the way, put them in. We'll try to get them answered, and then we'll have questions at the end to cover anything that need a little more clarity. So for the first slide up, what is crystalline silica and why should I care? First of all, as contractors, we got enough things to worry about. We don't need another thing to bother us. We're trying to figure out how to get production, keep the quality up, and the overall safety, and satisfy all the terms of our contracts. That's why I'm going to try to help summarize this so you don't have to do 10 years of research like I did to get to this point. The two pictures you see there, those are activities that happen on my job sites every single day. Some of it with respirators, some of it wet cutting, but on occasion I have to admit that guys were doing these type of activities and not wearing the right type of respirators or the safety equipment, because they thought, oh, it's only a few minutes, I can just do it and then get it done and move on. So what is crystalline silica, this SiO2? Here's what it looks like. This is a magnified view of it. Those are the dust particles, and some of the smaller ones you see and some of the larger ones you see. Pretty much everything that you see in that photograph is the stuff that floats in the air that when you cut. And when you do that grinding process, whether it's wet cutting or dry cutting, it creates a very, very small particles, shards of, they're a lot like shards of glass that float in the air. Now, some of you see this photo here. You see the picture of the hand with what I call silica snot. If you've ever been around these dry cutting tools for even an hour in a day, you know what happens. You cut, you get the dust in, you get what you can out, and then you go home at night, you take a shower, and you blow this green-gray goop out of your nose. That's the stuff that didn't get into your lungs. That's the stuff that you were able to cough up or choke up. Now, this picture right here shows the lungs that have near full capacity, and the dark circles, the dark areas, are where the air is inhaled. The contrasting picture next to it, these areas here where they are not dark, that is where there's scar tissue. And that's scar tissue from this silica dust that is right here. This dust, inhaling this dust, will create that scar tissue in the lung. So this is part of, why you need to care. This is the thing that we're trying to avoid. This is what OSHA is trying to avoid, and this is what we're trying to educate our people on, the proper way to go about this. So let's get into the OSHA silica PEL. This 100 micrograms of silica per meter squared. What does it really mean? I would tell you, as I started to do research on this quite a few years ago, and the more I read, the more I thought I understood, and then I realized I didn't understand, and then I got more confused as I read different standards related to the construction standard, the general industry standard. They don't make it easy, and if you're confused from reading it, don't feel alone, because I was very confused, and I talked to a lot of experts, both industrial hygienists, safety people, legal people, and nobody could really explain it to me in terms that I could get and wrap my mind around it. So that's why we tried to break the silica PEL down into a few different components. And here, first of all, what a PEL is. It's a permissible exposure limit. So how much of the substance can I safely be exposed to every day according to OSHA? And this is talking about just the crystalline silica portion of that. There are literally hundreds and hundreds of PELs that OSHA has. They have a PEL that regulates the amount of additive that's in the butter that they put on popcorns in the theaters. I mean, they regulate every different type of substance that can or may be harmful at different levels to people, and silica just happens to be one of those. So we're not being singled out from a PEL from the construction standpoint. There's many of them that they have to deal with on a regular basis. In this PEL, we've got three components that we measure, and the first one being air in cubic meters, the second one being the dust, specifically the silica dust in micrograms, and then the third component is time. And being as contractors, I wanted to figure this thing out. It's a math problem. It's something that we could wrap our minds around if we could just figure out the math and how to estimate it. So the three components kind of line up like this. You've got this air in quantities of a cubic meter. You've got the amount of dust that OSHA allows, which we know is that 100 micrograms. And then you have the time frame that they are inhaling this air with this amount of dust in it. So these three factors. Now, to get started with, we need to understand how much air a person breathes. And as contractors, we do estimates all the time. We started to dig and look and try to find different things. You see here, mowing the yard is a moderate activity that's somewhere around 35 to 37 liters per minute of air. General yard work. Car maintenance is less than that. Driving a car down the road, you're about 11. In our activity level that we were talking about and what we estimated and used was about 35 meters. So you see where I put the star right there. We're talking about 35 liters of air per minute that a person consumes at a moderate activity level. And if you're like me, you hope that your employees are at least working at a moderate activity level. Less than that, they need to go down the road and work someplace else. So we've got our first component of air that we've estimated at about 35 liters per minute. Now, if we take that number and run it out, here's our 35 liters of air times 60 minutes, which equals 2,100 liters per hour of air that is inhaled in and it's inhaled out. Now you take that 2,100 per an 8-hour day, you got 16,800 liters of air, and it's a metric system. It makes it fairly easy to calculate it over because it's 1,000 liters equals a cubic meter. So to boil it all down, we end up with this 16.8 cubic meters of air. Now here's a comparison of this box right here is 16.8 cubic meters of air. This is a liter of liquid, but that's the size of what 1 liter is. So you're breathing about 35 of those a minute at a moderate activity level. So, and this equals our full day's amount of air. If any of you have ever been scuba diving, you've used a 80 cubic foot tank. This is equal to about 8 of those in volume. And that, just for reference, that box is about 8'5" by 8'5" by 8'5" is the volume of air. So the next component that we are going to talk about is our dust size categories. And again, in life, the size of the dust matters. We have three different ranges that they put it in, and this is something that's used widely, and OSHA uses this, and so do industrial hygienists. You've got the size 1 is a respirable, which is 0 to 10 microns in diameter, aerodynamic diameter they call it. And then you have the size 2 that is 10 to 25, and then 3 that is 25 to 100. Anything larger than that, it's not in a dust category. The one that we're most concerned with is the respirable, because this size dust that is under 10 microns in size is the stuff that you will breathe deep down into your lungs. It is so small that you normally can't see it with the naked eye. The dust that you breathe into the upper parts of your lungs in the 10 to 25, and then the stuff that maybe gets caught up in your nose or in your mouth is in the 25 to 100 microns. And we've got a comparison chart here that just kind of give you an idea. If this large circle equaled a human hair, and the typical human hair runs between 75 and 150 microns in diameter. Now we're comparison of that in the average dust particles down here in the 5 to 10 microns, or bacteria or light dust that's in the 1 to 5 microns, and then we have fine bacteria, tobacco, and cooking smoke that are in the 0.3 to 1 micron. You see that there's very, very fine dust, and some people have made the comment about, well, what's the difference between working on a job site or going to the beach and you have that sand? It is sand, and there's silica in that sand. But when you take a handful of sand at the beach and you throw it up in the air, what happens to it? Typically, it falls right back to the beach. It's in such large sizes that it is not inhalable or respirable dust. It's not a factor. Now, if you took that same dust and you crushed it with a hammer, took a 2-pound sledgehammer and crushed it and powdered it and threw it in the air, then it's something you'd have to deal with. On the job site, we're dealing with different types of dust all the time, and specifically, as we're talking about, is the silica dust that we make from cutting concrete or drilling concrete or masonry materials is the stuff we're worried about. And all of that is in this 10 microns or less range. It's in this range right here. We have done a lot of sampling and a lot of testing here, and we took a test dust sample size in a test tube and sent it to a lab to measure particle size. And it was cut on a 14-inch blade saw, table saw, 100% of the dust, and they measured just under 10,000 particles with an electron microscope. 100% of it was under 10 microns in size. Almost 40% of it was in this range right here, between under 5 microns and in the range of 1/3 of a micron in size. Very, very, very fine dust. So fine that you can't see it even when it's floating in the air. While we're talking about that subject, you look at smoke, tobacco smoke, and you've seen someone blow, not so much anymore inside, but outside, somebody that is smoking a cigarette or cigar and they exhale that smoke. That is the size of the typical respirable silica that we're concerned with. The size of that is so small that it will float in the air for several minutes without being disturbed in the air. There's one study that I read that it takes 2 minutes to fall 40 inches for a piece of this dust that is suspended, that is in this range right here, this respirable range. It will float in the air for 2 minutes without any disturbance of air. And you can disturb the air just by waving your hands around. You will continue to keep that stuff floating. So it's it doesn't go away, as we know. It's still floating in the air, and that's one of the concerns that OSHA has about it, and part of the reason we want to understand better what the properties of this dust, even if we can't see it because it's so small. So under the next component here, if we know the size of the dust, and we know how much air that we breathe. So if our air equals 16.8 meters, cubic meters of air in an 8-hour day, and OSHA says we can safely inhale 100 micrograms per cubic meter, that gives us a total for an 8-hour day of 1,680 micrograms of dust. What does that look like? What does that mean? I'll give you a contrast. A typical paver cut, brick paver cut, or a brick, if you cut this in half, a 2-inch by 4-inch brick by 1/8-inch wide cut, you end up with 1 cubic inch of dust. Now, what does a cubic inch of dust look like? This is 1 paver cut right here. That equals, I believe it's about 93 million micrograms of dust. In contrast to what you see here on the penny, that is 8 hours of total dust that OSHA says it is okay to breathe for a given day. Now I'm going to introduce another factor here. This dust here, both of this dust that we're looking at, is not 100% silica. Its range is around 20%. So if you can imagine that only 20% of this is silica and 80% of it is other dust, that's the legal limit. Not total silica, but of only 20% of that being silica. I know this is a little bit confusing. If anybody's got any questions, certainly put them up, or we'll save them for the end. This amount of dust right here is many times less than this. This equates to 1 paver cut equals about 10 years worth of dust at the current level. So every time somebody cuts a brick or a paver and doesn't capture the dust and lets it fly, you're introducing almost 10 years worth of dust into the air at the current PEL. So if there's no questions on that, or we'll cover them at the end, the next thing we need to know is what is our exposure?
Joel?
Yes.
Before you continue, we do have one question. And the question is, can OSHA keep up with the fines, and do they warn you first?
Well, it depends, like all of them. The fines I've heard are starting at $5,000. Now, I also heard one last week that a guy got an $18,000 fine. That was just 2 weeks ago. He got an $18,000 fine. It depends on the area, and it depends on the inspector that's out there. They are going to be focusing on silica. They know that it's an issue, and they're going to be coming after it. And we all know the government wants more money from us contractors. What we can do to avoid it, that's what we're hopefully going to help educate people on. So did I answer the question?
It seems that there is the second part to that, and it says,
think
won't the fines go to the subcontractor, not me, the general contractor?
Well, there's exposure for both parts, because as a general contractor is responsible for any sub that's on the job, but the citation is going to go, because it's going to go to the general and the subcontractor. The sub will probably have to pay the fine. That's typically the way it goes down, but they'll both get cited, and there could be a small citation and a fine for the general, and then another a bigger one for the subcontractor that's directly exposing. But everyone on the job site has liability when this dust is introduced to the job. even the plumbers and electricians have exposure if they're allowing their employees to work around this type of exposure.
Okay, thank you. And just another question before we move on. Does water on the cut solve the dust getting in the air?
It helps. It definitely helps, and I'll cover that in more detail here in the options phase of this. We'll talk about the numbers on that. So back to the exposure levels. Knowing what your exposure is and having an education. I didn't know. I didn't know what my guys were exposed to, not from dry cutting, not from wet cutting, what the exposure levels really were. I will tell you from our testing, an activity like this or like this, you exceed the Pell in 5 to 50 times the Pell in a day. So if you've got guys doing this, or somebody on the job site is doing that, they're exposing themselves and the people around them, because if a guy's up on the scaffold with a power cutter like that making cuts, he may have a respirator on and he may be overexposing himself. He may not be, but certainly the guys that are 10 or 20 or 30 feet away, or the plumber that's just down the way, is going to be exposed also. So you've got the direct operator exposure, and then you have the people that are surrounding that have the exposure. So again, this type of activity, you are 5 to 50 times over the Pell. So how do you know that? How do you find out what that exposure level is? This is the way to do it, and it may be it's air monitoring. This thing right here, to make it simple, it's an air pump. Basically, it's a small vacuum pump it's got a battery in it. It's got a regulator that regulates the amount of air that is drawn in, and then you can see this hose that goes up over the guy's shoulder and clips onto his lapel, and this is a filter. So it draws in the air from around his breathing zone, which is the same area that his mouth, in this area, and it draws it into a small opening in the bottom here, and it captures the dust. It separates out the non-respirable, because the non-respirable dust will fall to the ground and the respirable stuff will float in this breathing zone. You set a timer on those, you measure the amount of time that you're going to have them and how much airflow, and that's how you calculate your exposure limit. It's fairly simple to do. It may seem a little complicated. If anybody has any questions and wants to move ahead with this, certainly get in touch with us here and we can walk you through it. It's not complicated. Once you do it once or twice, you will know. And I was nervous when I first did it, because as being a masonry contractor, I had an industrial hygienist company come out and they want to charge you $1,000 a day to put somebody on your job site, or $1,000 to $3,000 a day, and then they bring this equipment out. The equipment is much more readily available now, and I found a couple different companies, one of them being Galson Labs here, that will loan you this equipment, and the only thing that they ask is that you get the filters from them and let them test the filters, and they'll send you all this stuff for free. You send this sampler and this back to them, and they charge you less than $50 to take that test, and then figure out how much air went through it. You give them that information and they weigh it and separate it and give you a silica content. So for less than $50, you can have an air monitor test. I would recommend that you do 2 or 3 or 4 tests over each day for maybe a week. So if you make an investment of just a few $100 and get 6 or 8 or 10 of these cartridges from them, and run these on it with a guy or a couple of different guys, maybe over 3 days, and put this air monitor on, ask them to send you 2 or 3 air monitors. You can run them simultaneously on different people doing different work activities, and find out what kind of exposure you have over an 8-hour day. And this way, you know what you're doing, you know what you've got, and you have not alerted anybody to it. It's for your information only to to get this test results, and then you know what your exposure is. You don't have to listen to what I say or anybody else. You know exactly what your exposure is, and then you can start taking steps to do something about it. So again, you can contact Gulson Laboratories. They're real easy to work with. They'll walk you through how these things work, and if anybody has any questions on that, they can certainly contact us at a later time.
Joel,
Yes.
we do have a question. What is a safe distance for other workers on the job site?
Depends on which way the wind is blowing. As we know, if the wind is blowing right into your face and you're off the back of one of these, just a standard dry cut saw and doesn't have dust collection on it, this one has dust collection on it, being 20 or 30 feet away, you can still be overexposed depending on how much time. If the wind is blowing the other direction, that helps, but that doesn't help in the property next door or the crews that are working maybe 50 feet away. Because as we saw back in that first slide, the amount of dust to exceed the Pell is very, very, very small. It's much lower than we realized when we first started testing. And it seems like not a lot until you stack up and put 10 years of it into a vial and you look at that, or you put 20 years of it and say, you know what, I don't want to breathe that for 10 years or 20 years. I don't want my people breathing at that level, even at such a small amount. So it depends on which way the wind is blowing. The best thing to do is try to keep it out of the air to start with. So,
Okay, thank you. And so another question, or actually would like your opinion, do you feel that it is worse than smoking? And do you think that much of the lung cancer could have been related to silica? And would it allow for a second and third party lung disease to be possible?
I don't think I'm qualified to answer that question. I have an opinion on it, but I've done a lot of reading about the subject. People that have smoked cigarettes and have been exposed to this definitely have a higher likelihood of getting lung cancer. I'm more concerned with just the general population of construction. What concerns me is that as I travel across the country and I know what we did in our crews, is 80% or more of the people out there that are cutting. And it's probably not the companies that are listening in today. It's if you're listening in, you're concerned with silica and its safety on your job sites in general, and you're trying to get educated. But as an industry, I see that 80% of the people I've talked to and asked the question, what do you do? They just let the dust fly. They don't use any type of respiratory protection or take any precautions. They just try to hold their breath, put their t-shirt over their mouth, and they just go. That is the worst thing. And so I really can't comment or give an educated opinion on what causes cancer. I know what I've read, but is it a contributing factor? Yes, it is. How much so? I can't even give you a good answer on that.
Okay, thank you.
So from air monitoring, once you know what your exposure level is, either from somebody else using somebody else's air monitoring results or doing your own, and I recommend you do your own because then you know. This is what you'll get back. This is some test reports that we put together that has the different type of block material and the type of equipment we were using. What you're going to see is this information right down here in this box. And as you get used to reading it, and the laboratory will help you interpret what this is. You could see that they measured the air volume right here. It's 566 liters, 566.4 liters of air over a given time period. That's how much air the air sampling unit took in and filtered the air. The total amount of dust, the total amount of respirable dust here, you can see is 0.48, which equates to, it's 0.48 milligrams, which is 480 micrograms of dust. And then you can see down here the amount of micrograms of quartz in here, which is that's our silica quartz, crystalline silica, is 0.075. So that's 75 micrograms per cubic meter of air is what that is. So that tells us we're under the 100. The number right here is the percentage of silica content in the sample was 16. So this product ranges in between 15 and 25% silica content in there. In the beginning, it was very confusing for me, so once you do it and you get used to it, you'll see just like we did with a set of plans or a set of specs or a contract, you get used to it. There's only a few main things you need to be concerned with. It's the air, the amount of total dust, the silica content, and then you'll start to understand the silica percentage that's in the material. And again, the laboratories will be very helpful in helping you interpret the results that you get back. And again, you can keep this confidential. You know what you have, and no one can tell you you're above or below the standard when you know for a fact where you're at. So once you know the standard and you know what your exposure level is, the next thing that you need to be made aware of is what are your options? You need to know your options. And us as contractors, we like to have options. We don't like to get pinned into a corner. And if you're like me, you don't like surprises. I certainly don't like surprises, and that's one of the reasons I started pursuing the safety side of my business, because I didn't like surprise inspections. I didn't like surprise problems. We try to anticipate them. So one of the options is ignore the problem and keep doing what you've always done. Just let the dust fly. And there may be no one on the phone that's doing that today, but certainly there's a lot of contractors, especially the smaller ones, that are completely ignoring the situation, which is making it worse for the contractors who do try to comply, because OSHA tends to miss the small guys and they come after the larger guys who are doing a lot to improve their safety. So one of the options is to ignore it. I don't recommend that option. Another option is, somebody asked the question about wet cutting. Wet cutting reduces the silica dust in the air, in the breathing zone, by 3 to 5 times. And it can bring it below the Pell, depending on the work activity. I've read studies that have been done over the past few years on running a 20-inch masonry saw, 14-inch masonry saw like this, and they were still 2 to 3 times over the Pell in an 8-hour period because of the mist. Anybody who's spent a lot of time on a 20-inch masonry saw, it's it's usually not the top guy in the job. Usually it's an apprentice that's on the saw. I was that apprentice at one time. In the summertime it's not bad because you're getting wet all day, and you're around that mist that kind of gets on your arms, it gets on your face, it gets in your hair. That mist has the same silica content in it that the dust does. And basically it's just water droplets that have attached themselves to the silica, and you're still inhaling that. So you're not guaranteed to be 100% safe with wet cutting. That is something that we've always been taught, that there's not a problem if you wet cut, but you don't know until you do some testing to verify that if you are wet cutting, that it is reducing it below that level. And in the new OSHA standard, they have they've got a provision in there, a table that says that if you wet cut for less than 4 hours a day, that they think that you will be safe under those limits. You could be. You just have to do some testing to know for sure. Certainly, water reduces the amount of dust in the air. It's a good option when you can do it, but it's not a guarantee to keep your exposure levels under 100%. As all of you know, this slurry or water that comes out, sometimes it doesn't work on the scaffold. There's certain situations where you just can't run the water with it and you have to do something else. But once this dries, the next day or 2 or 3 days later, somebody's got to scrape up this slurry and do a cleanup with it. Well, if you're scraping and sweeping, you're reintroducing that stuff into the air, so you haven't really gotten rid of it. It's on the ground. You've knocked some of it down, but you have to be cautious about what happens when you're scraping the mess up later on, or trying to do cleanup, whether you're cleaning up, trying to clean all the slurry off your saw at the end of the job site. Next options that come up, you could build your own. This is a very primitive one of the first ones that we built for a dry saw that it worked very well, but it took a lot of time to do cleanup on it. So we've seen a lot of different contractor methods to try to deal with creating vacuum systems or fan systems to blow the dust in a different direction. There's becoming more and more commercially available vacuums and shrouds and things that are available to us as contractors that weren't even available just even 5 or 10 years ago. Getting a good vacuum. Now, this is not just a standard shop vac from Home Depot. This has the right kind of filter in it. It's got a filter pulse system that will clean or bang out the filter internally on an automatic basis. You shut it down and it will knock the dust off and get it down in here. If any of you have ever tried to use just a regular shop vac filter from Home Depot, or one of the ones that's commercially available shop vac, typically running a tool like this or a tuck pointer or something like that, you're going to plug that filter up in less than an hour, and it could be in 15 or 20 minutes you've overloaded the filter and it's not effective anymore. So there are more and more options out there for tools to use. This is a photo from a test that was done several years ago in New Jersey, and they tested wet cutting on a 14-inch saw. They ran it wet, they ran it dry, they ran air monitoring, they put fans to it. Very interesting. They did a comprehensive test on it, but you see what's involved in this whole thing. I don't know any guy that ever worked for me that said, yeah, boss, I'll be fine. Just put me in this space helmet thing here and let me drag that vacuum around and this thing connected to that thing. They won't do it. You know it, and I know it. The guys on the job site just will not be that encumbered to try to make this happen. But this is a safe way to do it. He's got good respiratory protection on. This has a pump in it that pumps fresh air up into the helmet, and again, he's got the vacuum system working here. Not totally practical in most situations on a job site. There's many more commercially available units that are being built out there. Some plastic shrouding for quickie saws, cutoff saws, shrouds, skill saws. Again, if you get one of these type of systems, you see that you have to add a vacuum to it. There's recommendations for the size of vacuum. They will not work well for an extended period of time with a standard shop vac. You have to get a good shop vac that's made to collect the type of dust that we're dealing with here, and made to do it on an ongoing basis on an 8-hour period, or even a 4 or 5 hour period while plugging up. And remember also, when you go back and clean up something like this, you open this thing up, you've got dust that you're trying to deal with. You've got your exposure level that is prevalent, and you have to have either a respirator on the guys or a clean way to safely dispose of that dust, because until it's completely disposed of, you still have liability associated with it. Now, this is one of the systems that we developed for the 20-inch saw, one of the first systems, and that draws the dust down inside, and there's a series of filters in here. This is a table that's adaptable to several different 20-inch brands of 20-inch saws, and it's got the dust containment down in the bottom. You can collect 50, 60, 70 pounds of dust, pretty much cut an 8-hour period without having the dust to deal with. And some of the other options that we have, this is a masonry cutoff saw. with the, again, this has a vacuum system, a filter system, and dust containment here that draws the dust up inside, and then you can drop this dust into a bucket and deal with it at that point. Well, works good as a portable basis. And then 14-inch saw here with a vacuum system draws the dust down inside. You can work inside 8 hours a day with a product like this and maintain below the OSHA PEL, 80% below the PEL. Again, this has a filter system built in, a vacuum system, and dust containment all as part of it.
Joel?
So, yes.
Are there any suppression systems available for mixers or cleanup tanks?
For mixers commercially available at this time, I am not aware of any. A cleanup tank, what is a cleanup tank? I'm not familiar with that term.
Let me see if it was from Jim. Hey, Jim, let me unmute your line. Can you hear us, Jim?
Yes, I can. I was asking about cleanup tasks when you're cleaning up, dry sweeping. We typically try to put water down and wet things down where we have to do sweeping. But I wanted to ask Joel if there were any kind of systems that they had for keeping the dust down when you're doing those types of tasks.
Yeah, a cleanup task. I thought it was cleanup tank. We do not have anything for the sweeping process. We're using sweeping compound for ourselves when we're cleaning up around, and that's certainly one of the areas, because every time you go to try to sweep something, as we know, you reintroduce it into the air. You scrape the floors and you got to sweep them. You have some liability there. The biggest exposures we have in our trade, in the masonry trade and the hardscape trade, is certainly the cutting. If you're cutting, coring, or grinding, either wet or dry, we're creating that real fine powder slurry, which is the stuff that we need to be most concerned with. And as far as new components, we have 10 new components that we're working on to help the industry, but we don't have anything available for a mixer at this point.
Okay, thanks, Joel. And is it just inhaling the silica dust, or can your eyes also absorb it?
Inhaling it is the most prevalent way, but also just getting it into your saliva and swallowing it. In your eyes, we've all had dust in our eyes. If you've ever ridden motorcycles in a dusty day or been out, you get the dust in your eyes. It's not good for your eyes. But inhaling it and swallowing that dust, because that same silica dust goes down into your stomach, and you can get colon cancer from this stuff. It's the more I learn about it, the more I realize how nasty it is. So whether you swallow the dust or you inhale the dust, it's bad for you internally to be around it.
Okay, thank you.
So we're covering what our options are, knowing what our options are. As we talked about wet cutting with slurry, you've got the slurry to deal with and the silica mist to deal with. The slurry you have to deal with when you come back and it dries, and you got to do cleanup. And in some cases, you've got a problem with the slurry on your block. The other option you have, one I don't recommend, is cut dry and let the dust fly. That is something as an industry we've got to all push to eliminate, even for our competitors, because it just gives us all a black eye in the masonry hardscape world. Finding solutions to clean cut with engineered vacuum filter systems, that is an area that is more options are becoming available all the time. And I think that's one that we'll see more and more of, because you can eliminate the mess right at its source and keep it off the job site, so you're not having to come back and do cleaning or sweeping, or you're not getting the mess on the brick or the block when you're cutting them. Those are certainly some of the new things that are happening. And all of us that have been around this for a long period of time, I remember when you had to wet cut and dry cutting first started, and we were pretty excited. I bought my first dry cut blade, and the early 80s and put it on a table saw and was cutting brick and thought, man, this works really well. And then I put my t-shirt over my nose and was trying to keep the red dust from going up into my nostrils. But you know, things have changed, and now the more we learn, the more we can protect ourselves and our people. So again, knowing your options, knowing what your exposure is, and know what your options are. So hopefully we've given you kind of a quick overview of what the standard is, knowing what your exposure is, and then knowing your options. So as contractors, we can take action and create a better environment for our people to work in. Anybody that's ever worked around the dust and the mess knows that it's not a fun job. So keeping it cleaner out there on the job site for our guys, they're going to be more productive in an 8-hour day just because of the better work environment. Is there any questions we'd like to cover that have come up, or a little deeper explanation for some of the things that I may have skipped over a little too quickly?
Well, one of our attendees has a little bit of information that they would like to share that says the Work Safely with Silica website includes a free contractor planning tool that includes commercially available examples of equipment controls for a variety of dust-producing operations, including cleanup. It's www.silica-safe.org. There was an article about this in the MCA magazine, and it also includes some of your IQ Power Tools equipment is among some of the examples that are on the Silica Safe site.
Yeah, if any of you have not had an opportunity to go in there, that's available to everybody. That's a really good site, and they kind of walk you through step by step of developing a silica plan. You put in what your exposure is, what type of tools you're using, what type of material you're cutting, and it'll walk you through and give you recommendations for a lot of different options like we talked about today. It's a good program, and I believe it's available to anybody on the internet that wants to use it.
Okay, and how do your employees safely clean the vacuum/filter systems?
Each tool has a little bit different way that it's done, but the like on the 360, the two smaller portable ones, you just spin the filter to clean it, and it knocks the dust down into the bottom, into the dust containment area. On the PC912, the gas powered cutoff saw, then you just open the door and it drops into a bucket. Then you have to deal with it from the bucket. You can put a bag on a bucket and contain it in there and capture it and put it into the trash, or you can recycle it right on your job site. You can add it to mortar, or you can lose it into the subgrade on the job site. Put a little water onto it and lose it right on the job site, and blend it in with the material that's there. So recycling is something that we're advocates of, not have to haul it off to landfill, but being able to use it right on the job site as a filler material. Thank you.